It was a decade when technology rocked. Creating a phone you didn't dial, a watch that never ticked, and a camera that captured a giant leap for mankind, using the same power it takes to light a Christmas bulb. Discover the secret under the hood of this Mustang rental, and find out what's inside the toys that etched an enduring and super legacy. Now, 60s Tech on Modern Marvels. In the words of the generation that defined it, the 1960s were groovy. And if one 60s gadget traps the spirit of the time in a bottle, it's this psychedelic icon, the lava lamp. Part of its intrigue then and now is that the company that makes it won't divulge precisely what's inside that makes it work. Employees at the lava lamp factory take an oath of secrecy when they're hired to ensure that the mysterious ingredients stay a mystery.
We don't really know what's inside here because it's a closely guarded trade secret, but what we do know is that the two substances are very close in density, and one of them is a waxy substance and the other is a liquid. If we pop the top, we can actually separate them and see the differences. Here comes the wax. The wax is already starting to harden, and you can see it's just like candle wax that's been melted.
The key to the motion of the blobs within the lamp is the light bulb in the base. It keeps the wax from hardening and sinking to the bottom.
The heat melts the wax and then expands it just a little bit so that it's less dense than the liquid around it and it can rise. As it gets up to the top, it cools, contracts just a little bit, gets more dense and is able to fall back down to the bottom. And that heating and cooling, expanding, contracting process is what gives this its amazing, mesmerizing look.
As lava lamps were making globs of hot wax cool, another fad of the 60s was making pint-sized cars huge. America's slot car craze began in 1960 with 2 commercial raceways. But by 1968, their numbers had swelled to almost 5,000.
Some of them were as large as bowling alleys. I remember a track I raced in having 9 large tracks.
Early slot car hobbyists like Ed Harris built their own elaborate tracks and even their own cars.
We built them ourselves from a static model kit, and then you found a motor somewhere, usually old train motors, and then you put it together yourself. I had scrounged up gears and tires and so forth, and we went from there.
60 slot cars may have resembled real automobiles, but their unusually high power-to-weight ratio gave them acceleration that could make Mario Andretti drool.
Slot cars are the world's fastest motorsport. A slot car goes from 0 to 130 miles an hour in under half a second. There's no real car that comes close. All slot cars get their power from the track, so they have a motor, but no batteries or power source in the car.
Pulling on the trigger of the controller causes electric current to pass from the power source to the track. From there, rails feed the electricity to the car's motor. The more the trigger is depressed, the greater the current, and the faster the car drives.
In a way, you might say like driving a car. You come into a corner, you got to slow down, and you either back off on the throttle, and then you've got to time the speed going around the curve. Go too fast, and you're going to go off. And if you don't go fast enough, somebody's going to pass you.
By the late 60s, slot cars had really reached a peak. There were thousands of tracks all over the country, but interest started to wane, so the manufacturers looked for another way to appeal to the racers, and they came up with the Thingy. The Thingy was a dramatically styled car that they thought would appeal to the youth and racers. And these are some examples. An Asp by Classic, the Gamma Ray by Classic. This is a Garvin car and an AMT car. They were popular, especially with kids. In fact, Classic's Manta Ray was the best-selling slot car of all time. But they were very unpopular with those who had hand-built accurate models. So it really split the industry, and many people believe began the collapse.
By the end of the decade, the slot car craze was on its final lap. But the decade produced other toys so enduring that they're now hitting middle age, including everyone's favorite, the Etch-a-Sketch. Its origins date back to the late 50s, when inventor André Cassagnas devised a contraption in his Paris garage he called l'écran magique, the magic screen.
Etch-a-Sketch, the toy you'll never tire of.
In 1960, the Ohio Art Company brought it to America, renamed it the Etch-a-Sketch, and sold millions of them.
It was very, very popular in the 60s because the whole nation was TV crazy. Everyone was crazy about the television. And here was a toy that, was on the market that basically looked like a TV. Kids could draw in it. Also, Etch-a-Sketch was one of the first toys to actually have a commercial on television.
The timeless two-knobbed teledoodler has remained relatively unchanged since its introduction.
If you've ever wondered what's inside, we have the taken apart Etch-a-Sketch here, and it's really simple. You've got a stylus, which is what pushes the powder off the glass to make it draw. We have a pair of rails, and really what we have is the essence of a computer plotter here. And then we have the magic ingredient that allows you to erase, a combination of aluminum beads and aluminum powder. And you might be wondering, why would this aluminum powder stick to the glass? And it's because this aluminum powder sticks to everything. It's really clingy stuff.
The left and right knobs enable you to draw horizontal and vertical lines. Most of us have mastered stairs, maybe a house. But Etch-a-Sketch artists like Christoph are etching and/or sketching their way to a whole new artistic level. To approach such expertise, you have to master a basic but important technique.
Basically, the secret is you have to use both knobs at the same time. If you use the knobs inward like this, you create a diagonal line. Now, if I were to use the knobs side to side in motion, you're creating the other diagonal line. And then, if you use the force, you can create a circle.
And from there, the possibilities are endless. But be warned, once your masterpiece is finished, be sure not to shake it. The Etch-a-Sketch isn't the only 60s toy that continues to fascinate us. Case in point, that lively ball with a super-duper bounce.
Super Ball Regular made from Zectron with 50,000 pounds of compressed energy.
When the ball was introduced, it was so revolutionary and so high bouncing that it started to develop rumors around it about where this magical rubber had come from. And, there was stuff about outer Mongolian specially bred rubber trees and all kinds of crazy stuff. People wondered, is there some kind of magical device or spring or something inside here that gives it its bounce? But if you go and actually cut it with a knife or a saw and look inside, it's just solid rubber all the way through.
The ball's ingredients are essentially polybutadiene rubber, the same kind of rubber used to make most tires, and sulfur. The mixture is forced into a mold, heated to 320 degrees Fahrenheit, and pressurized upwards of 1,000 pounds per square inch, so that the sulfur molecules cross-link the polybutadiene chains. The secret to the super-sized bounce is adding about 4 times more sulfur than in conventional rubber products, forcing more connections. More cross-links make the Super Ball more resilient, enabling it to bounce back to 92% of the height from which it's dropped, no matter how high that happens to be. But the Super Ball's real superpower comes when you chuck it.
You could just whack it into the ground and it would go like 3 stories higher, so that it was shocking how bouncy these balls were. And that was what made such a huge impression. Whammo sold millions and millions and millions of these things just because there had been no ball like this ever in the history of mankind. It truly was a super ball.
Although kids had a ball playing with innovative toys in the 60s, the decade was anything but all fun and games. We were reaching for the moon, and we relied on one custom camera to bring the singular moment back to Earth.
Got your feet underneath you.
When American Football League founder Lamar Hunt watched his children playing with a Super Bowl, he came up with a new name for the so-called AFL-NFL World Championship game, the Super Bowl. 60s tech will return on Modern Marvels, here on the History Channel. We call it everything from the boob tube to the idiot box. But there's no denying many of us are totally hooked on television. We can trace our obsession to the beginning of the 60s, when the evolving medium had found its way into 90% of American homes. It was influencing everything from our shopping choices to politics.
The Nixon-Kennedy debates was probably the first time that television had a significant effect on the outcome of the election, purely because of the way Nixon looked compared to Kennedy.
TV's influence blasted to new heights on July 10, 1962, when NASA launched Telstar, the world's first commercial communication satellite. 3 Earth stations stood ready to transmit television signals to and receive signals from the orbiting satellite. One in Goonhilly Downs in the United Kingdom, one in Ploumeur-Boudou, France, and one in Andover, Maine. 15 hours after Telstar's launch, Andover technicians crossed their fingers as they tried it out for the first time.
The first broadcast was made over Telstar 1 from here, and it was an image of the American flag flying in front of the control building to Ploumeur-Boudou, France, the Earth station in Europe.
The pioneering event marked the beginning of the instantaneous global communications revolution. The Andover Earth Station is still in operation today. Its location is ideally suited for satellite communications.
We're in a bowl here with the mountains completely surrounding this Earth station. And the mountains around here in this bowl prevented unwanted radio interference to the satellite signal. And also, we're in the northeastern part of the United States, which gave us a short loop to Europe for satellite communications.
Andover's equipment may have gone through 4 decades worth of upgrades, but its transmission process has remained essentially the same. To transmit TV signals, Andover's engineers in the 60s uplinked broadcasts, then beamed the signals toward Telstar.
Sending station identification.
Telstar traveled in an elliptical orbit between 600 and 3,500 miles above Earth. It was equipped with antennas that received the signals. Then Telstar amplified them 10 billion times using traveling wave tube amplifiers and transmitted them to one of the other Earth stations. Technicians at those stations were able to move their ground antenna to optimize the connection.
In the days of Telstar, the antenna that was used for that was very large and very mobile because it had to rotate on an axis and then travel on a track as it followed the satellite across the sky. So the antenna would literally move in order to be able to follow the satellite clear across the horizon from one side to the other.
Telstar's oblong orbit caused the satellite to be in position for transatlantic relay for only 20 minutes every 2.5 hours. Today, most communication satellites are in geosynchronous orbits, matching the speed of Earth's rotation and staying fixed above one specific point below. enabling them to relay signals 24 hours a day. After our TVs capture those signals, we take it for granted that we'll be seeing the images they carry in color. But until the 1960s, most of us were still staring at screens filled with black and white.
Color television as we know it today was invented in the 50s, and the first sets were introduced to the public in 1954, but they didn't sell very well. There were a number of reasons for this. One was that the technology was crude, the sets weren't reliable. Another was that the networks didn't do much color programming because it was very expensive and they had few viewers. Finally, in the mid-60s, television took off because many of the technical problems were solved.
So how did they get color TV to work? You might be surprised to find out that the encoded analog signals broadcast by the networks and local stations weren't in color. The color on your screen then and now is made by interpreting wave frequencies here inside the television itself.
Television signal comes into the antenna connections here. It goes into the tuner, which is located up inside where the channel is selected. The signal is then processed by these circuit boards, which create the black and white signal. This circuit board is to extract the color signals, red, green, and blue. They're then sent to the picture tube. And you can see I have another tube here. Inside the tube is 3 electron guns, one for each color.
These guns shoot beams of electrons toward the screen. The beams pass through a shadow mask, a plate dotted with thousands of holes. Behind each hole is a group of 3 phosphors, substances that emit light when excited, one for each color. When the electron beams strike these phosphors, they light up. If all 3 beams fire at the same time with the same intensity, they produce a white dot. If all 3 are turned off, they produce a black dot. Combinations with varying degrees of intensity create all the other colors. Pull far enough away from the individual dots and you get the big color picture. The technology won over 60s consumers. Many plunked down upwards of $395 for a new 24-inch color set.
There was more detail, there was more to see, it was more graphic. Something like watching news of the Vietnam War, all of a sudden people could see blood in color, and that was very striking and very memorable to people and had an influence on the anti-war movement.
Despite the revolution in color TV, the 60s' most eventful television moment would be broadcast in black and white. On July 20th, 1969, more than 600 million mesmerized viewers tuned in to watch man's first steps on the moon.
It's one small step for man, one giant leap for mankind.
It was a broadcast television feat that would require an unprecedented technological leap. It began when Stan LaBar, a Westinghouse engineer, was given a seemingly impossible task. His challenge was to design a compact camera, rugged enough to operate in the extremes of the moon environment, and transmit the video signal 238,000 miles back to Earth.
When we were faced with this, it was rather amazing as how the group that we pulled together suddenly became so focused in on this particular problem, unlike anything we had ever done before.
LaBar and his team had to make the camera simple enough for the astronauts to handle while wearing their spacesuits, and strong enough to withstand lunar temperature extremes of 250 degrees Fahrenheit to 250 degrees below zero. One of LaBar's most daunting challenges was to make the camera function using extremely limited electrical power. NASA project leaders had to allocate the lion's share of power to more essential hardware, leaving precious little to spare.
They limited the amount of power that we could use on a camera to 7 watts. 7 watts is the power from one Christmas bulb.
Power restrictions also limited the bandwidth of the camera's signal to only 500 kilohertz, 1/8 the bandwidth of a conventional television signal. This This forced the team to come up with a radically new format for the camera.
Your home television works at 30 frames a second. This one scans at 10 frames a second. Your home television had 525 lines, scan line. This one only has 320.
I was informed at the time that this camera would be of a format that had to be converted or it would not be able to be seen on regular broadcast. So we had contracted with the RCA Corporation to build a converter so that when we received this signal at the ground site, we would be able to convert that prior to transmission back to Houston and release to the public. We had a 210-foot dish in the Mojave Desert. We had one in Madrid, Spain, and we had one in Australia, which covered a 360-degree Earth as the Earth turned and our view of the moon changed.
Tranquility Base here. The Eagle has landed.
When we landed, at that point, I would say within 30 minutes, it became a realization that this television that was nice if you could get it but not required became the event, and it became the quote-unquote requirement. We better see the first step on the moon.
Apollo 11's camera and the complex transmission and conversion processes worked almost without a hitch. The images lost a fraction of their clarity on their way from Australia to Houston. But even though the image broadcast was blurry, it captured Neil Armstrong live, making a giant leap for mankind. Ironically, NASA has lost the tapes of the cleaner transmission beamed to Australia. All that remains of it is this filmed image of the Australian monitor, shot by a technician at the relay station. But the lunar camera has had a lasting impact, raising the bar of TV technology. 60s TV also introduced us to the car that captured the decade, a stylish beauty that many Ford execs never wanted to make. At the beginning of the 60s, an ultrasonic remote control added about 30% to the cost of a television set, or $100 for a $350 set, the equivalent of roughly $700 today. 60s tech will return on Modern Marvels, here on the History Channel. There's just something about a 60s Mustang. If any car could claim the decade, this was it. More than 40 years since its introduction, this legend of the American auto industry still has the ability to turn heads and trigger envy. It's no wonder everyone had to have one in the 60s, and why many still want one today. In the early 60s, Ford general manager Lee Iacocca realized that the boomer generation was coming of age, an untapped market crying out for a car to call its own. In 1964, Ford unveiled the Mustang.
It caught the entire United States' fancy. Everyone wanted a Mustang. Everyone wanted to be seen in a Mustang. And sure enough, within the first 2 years, they sold over 1 million cars. The first year sales had set records no other car had sold in those numbers. And it was all because the car was the right car, the right price, the right time, and it had the right look.
Ironically, this automotive icon was almost the car that wasn't. Ford executives had to be convinced by Iacocca that they needed his car instead of their Falcon.
Well, when he first pitched the idea of this youthful young car, it was basically summarily thrown out. And the answer was no, no, over and over again, no. So that's when he decided, let's leave the glass house. Let's get out of there in Michigan Avenue, drive up the street, stop in a little motel called the Fairlane Motel, rent a room, and think outside the box, if you will. I mean, go there, go off campus, let's think this through. And sure enough, that's where the Mustang was born.
Although Iacocca's design team did just that, they also used the Dowdy Falcon as their starting point.
This was a typical Falcon, 1963. The Mustang is based on the car except for the styling. Basically the same platform as the Falcon. It's a unit body car, which means it's all one unit. It doesn't have a separate frame that the body bolts to. And then they added these torque boxes out here, which is, again is just steel plates but it added strength to the frame of the car and kept it from flexing.
Ford designers took the Falcon's platform and engine assembly, then shortened the wheelbase, lowered the seating position, reduced the trunk space, and elongated the hood. They also gave it a well-appointed interior and wrapped it in its sleek signature body style.
When they went ahead and they decided they were going to build a four-seat sporty car, there was a lot of debate about what the name should be. Some people wanted to call it a Cougar, and the name Torino was tossed about.
The debate ended when they turned their eyes on this unusual car.
This car in front of me is known as the Mustang 1. This little car came out in 1962 as what they call a concept car. It was the first Ford car to bear the name Mustang, and it was a sensation when it came out. Ford really just borrowed the name Mustang from this car. And eventually, they decided to take advantage of all the good publicity that this little car had generated to call a production car a Mustang.
In the spring of 1964, Iacocca's brainchild finally hit the market.
And when it finally hit, it took the country by storm. There are great stories about people staying outside their dealerships and crowds that couldn't be contained. Every car that was in the dealership on the first day selling out.
Boasting a starting price of around $2,500, the Mustang appealed to just about everyone. You could buy a Mustang as a hardtop, a fastback, or a convertible.
One of the keys to the Mustang's success was that you could make it your own. And it's very hard today to find two of these early Mustangs that are exactly alike.
Any proud classic Mustang collector will tell you the same.
This is a 1966 convertible. It has options of power steering. The most exciting thing is it has air conditioning. We don't find options like air conditioning on convertibles.
This is a 1967 fastback, and it's got a neat option in here for people who like to ski. You can open up the trunk and set your skis in, and they go all the way through to a fold-down rear seat.
This is a 1968 GT. It's a high-performance 302 motor with a factory 4-speed. The wood option in the car is a deluxe interior. I have totally rebuilt this car from ground up.
There was even a Mustang for drivers who demanded something brawnier under the hood.
This is a 66 GT350. Carroll Shelby took the regular Mustang and 65 on up and modified it to be a little more performance-oriented. What he did was a few modifications to the car that you normally don't have on a regular fastback.
Modifications included a V8 racing engine and a special intake manifold and carburetor to increase its power from 271 to 306 horsepower.
Most people would prefer to have these if they're a little more speed-oriented, a little more racing, a little more prestige. It's more of a rare car than a regular Mustang. Shelby didn't make that many of them.
Not everyone could own one of these wild Mustangs, but that didn't mean you couldn't drive one.
Hertz realized that there could be a real marketing opportunity here for renting cars to people who couldn't afford to buy these things but wanted to be able to drive one. And they worked with Shelby, created a number of special GT350s. They were painted black and gold, which were Hertz's colors. They were called GT350Hs, and you could go in and rent one.
People used to come in and rent them for the weekend. That's why they called it a rent-a-racer. And they'd take them out to the drag strips or they'd take them out to the oval tracks and they'd race them. And then they'd bring them back Monday and they had a good weekend and it didn't cost much. Then guys started deciding that, hey, we can take these engines out of the Shelbys and put our less powerful engines back in them and use these in our everyday cars. And Hertz didn't know the difference. They were not car aficionados. They were just in the rental business.
Today, you can still rent your own racer, as Hertz is once again offering the Shelby to its customers. What the Mustang did for the 60s car industry, this push-button wonder would do for communication, and this humming watch would do for timekeeping. In 1999, a man in Tennessee applied for a license to marry his Ford Mustang. He listed his fiancee's birthplace as Detroit, her father's name as Henry Ford, and her blood type as 10W40. His application was rejected. 60s Tech will return on Modern Marvels. The 60s was the first decade to rock and roll from beginning to end. And you could take the dance party wherever you went.
No one had ever had that ability before. You could walk around and listen to your music, and even though it sounded like crap, no one really cared. It was so amazing to be able to do it that you were happy about it.
The gizmo that made the transistor radio possible was, of course, the transistor. In the late 60s, this tiny electrical wonder was making a huge impact.
Transistors are a pivotal technology, like a wheel or fire. They are so amazing in electronics, in computers.
We have here what are called discrete transistors. These are probably from the 60s and 70s. They're called discrete not because they don't tell secrets, but because they're individual transistors, each one packaged in a separate header, as they're called in the business.
The transistor had been invented in 1947 by 3 scientists at Bell Laboratories, looking for a replacement for inefficient and bulky vacuum tubes.
They found out that they could control the current through this piece of crystal by the voltages they put on the wires. And they could put just a little bit of voltage, a little bit of current on the wires, and they would cause a large current change through the crystal.
In the case of a transistor radio, a weak signal travels from the antenna through various components to a transistor. There it's amplified. The amplified signal is then directed to the speaker that translates the signal into audible sound. Electronics manufacturers of the 60s wasted little time capitalizing on the new technology. Transistor radios hit the market by the mid-1950s. But it wasn't until Japanese companies like Sony streamlined production that they became as affordable as they were desirable.
In the 60s, Hong Kong and Japan took over the transistor marketplace and began producing really cheap radios to the point where they dropped from 40 to 30 to 20 down to $10, and then everybody could have one, and everybody did want one.
As transistors helped give our radios a makeover in the 60s, they did the same for that other electronic necessity, the telephone. Until 1964, all home telephones featured a rotary pulse dial, where the series of pulses corresponded to each of the digits on the phone. Consumers at the 1964 New York World's Fair got a sneak preview of things to come as touch-tone phones were put to the test.
Hi, this is the Bell System's new touch-tone dialing. With this indicator, you see how many seconds you saved the new way. Let's try it. Okay, I'll race you. Ready? Go.
They were an instant hit and literally set the tone for the future of telephone dialing.
I beat you.
Once you tried the touch-tone phone, you just did not want to go back to the rotary phone because it was so darn slow. It was just, you had to turn it and then you had to wait. If you had to do a 0, forget about it. It just took forever.
Your finger and your patience both got some relief.
If you look at this phone, you can actually see how simple it is. When you push a button, you're generating like a contact between 2 pieces of metal here, and that contact is hooking to a tone producer, and there's 4 tone producers down this line, and there's 3 across here. When you push the button, 2 separate tones are combined, and that's what's sent down the line. The reason they wanted to use 2 tones was that they didn't want your normal voice or any whistles in the background or something to get picked up and interpreted by the system.
In the 40-plus years since its inception, The touch-tone phone has saved each of us an average of over 400 hours of dialing. Innovations in the 60s not only revolutionized the way we made phone calls, but also changed the way we kept time. For 300 years, watches ticked. But Accutron had a fluid motion and hummed.
What I have here is one of the original Accutrons from the 1960s. It was originally launched in the 1960s by Bulova Corporation. It was the first revolution in 300 years in timekeeping. Prior to that, all watches were mechanical. They had a balance wheel which rotated from 3 to 5 times per second.
The Accutron was different. Instead of a rotating balance wheel to create the watch's constant regular motion, it used an oscillating tuning fork.
This is actually a tuning fork that was in one of the movements, and what happened is you had a circuit that created an electromagnetic field.
The electromagnetic field created by copper coils vibrated the magnets at the end of the tuning fork 360 times per second. As the tuning fork vibrated, an index finger attached to it pushed and retreated, forcing a gear wheel to turn.
A tuning fork was not new to timekeeping. Actually, in 1866, there was a patent issued to Breguet to put a tuning fork into a clock movement. But it wasn't until the miniature of the transistor that it was capable of being put into a watch that one could wear on the wrist.
Bulova engineers had begun working on the concept of an electronically driven wristwatch in 1953. After years of effort ticked by, Bulova introduced the Accutron to consumers in October 1960.
This was one of the most popular models, the 214 movement with an open face. It was called the Space View. And it was actually the jeweler's suggestion that we have the watch with an open dial. When we showed them the technology in a prototype, they said, boy, it would be great if we could show off that technology to the consumers to explain how it works.
Consumers purchased over 4 million Accutrons until production stopped in 1977. Surprisingly, it still attracted buyers well after quartz crystal technology, with its ability to oscillate at over 32,000 vibrations per second, had trumped it in accuracy.
People are very passionate about their Accutron, not only because it is a historic item, but it's also a collectible.
Time was running out on the 60s. But the trip wasn't over, as the freewheeling counterculture still had its technological mark to leave on the decade. The 9-volt battery was introduced in 1956, specifically to power portable transistor radios, which required a higher voltage than supplied by conventional 1.5-volt batteries of the time. 60s tech will return on Modern Marvels, here on the History Channel. Among its many signature features, the 60s had a distinctive sound all its own. A sound that expressed the rebellion of a new counterculture that felt free to tune in, turn on, and drop out. This restless generation gathered to create the ultimate youth event of the 60s, Woodstock. The sound guru who made the music blast at Woodstock was audio engineer Bill Hanley. Hanley still has the audio artifacts from the festival tucked away in his backyard sheds.
These are the mixes that we used at Woodstock, and this one and that one. These are different style ones that we had.
Hanley's greatest challenge at Woodstock was to make the music audible to the audience furthest from the stage.
I actually picked the site for Woodstock and designed and laid it out so that the crowd went up in an amphitheater type operation. I designed the walls to funnel everybody in so that they would be in the range of the speakers. We never expected that big a crowd, so what we ended up with is people everywhere.
The audio requirements of large rock festivals compelled sound engineers to mic the instruments, an innovation of the 60s that's now commonplace.
That's the change.
That's the big change of in technology that we used. So I mic'd all the drums. I mic'd tom-tom, the floor tom-tom, the kick drum, the snare, the hi-hat, the cymbals up above. I had 5 or 6 mics on the drums, which was, not really done until 68, 69, except for people like Bill on large shows.
Before the 60s, engineers had purposely avoided miking the instruments, since gathering too many mics on stage created a greater potential for feedback. Feedback is that annoying noise we've all heard, caused when an audio loop generates between the microphone and the loudspeaker carrying its signal. But a solution to the problem arrived with the introduction of the Shure Unidyne 3 family of microphones in 1959.
This microphone was the most important advancement for the public address systems and sound reinforcement systems of the 60s era.
Before this generation of microphones, the most popular mics picked up sound in a wide pattern around the front. But this new end-firing model picked up sound in a narrower pattern from the top end.
It's like a Christmas tree, like that, upside down, facing in. And people, if you talk in that way, you got a good pickup. If you talk in this way, you got very little pickup.
The compact conical end-firing design, with its innovative acoustical chambers, gave it incomparable feedback control. Engineers could now put numerous mics on stage and use massive speakers to amplify the sound, powering the rise of rock concerts and festivals as we know them today. '60s rock shows were not only an auditory spectacle, but also a visual one. Visual artists like Joshua White were the men behind the psychedelic curtain.
What was there before light shows came on the scene? Nothing. There was nothing there. It was a completely different time. It was the 50s, and everything was gray. And you went to a concert and you sat and watched the band, and there would maybe be a curtain in the background, and maybe there'd be a follow spot. But at the end of the 60s, the music began to really change and grow, and it took on a very distinctive American psychedelic flavor. And there was nothing to look at. It was brilliant to listen to, and there was nothing to look at. And there was a window of opportunity for the creation of the psychedelic light show, which was something you looked at while you listened to the music.
So how did light show producers like Joshua White create this larger-than-life psychedelic art?
This is the heart and soul of what the original light shows were. It's a overhead projector, the kind that we used in high school. And then we took clock faces, and this is literally a face off of a clock. And then we began with the first and most primary thing that everybody remembers about a light show, which was the liquid part of the light show. So we took water, and then we took oil, common, ordinary mineral oil, and we would squirt it on top of the water. And this is the great secret revealed of psychedelic light shows, is that oil and water don't mix. And then we would add a little bit of color. Now you can add other elements to it, so that you can take something as simple as alcohol and squirt the alcohol in, and the plate begins to take on psychedelic qualities of its own. Everybody thinks I'm doing this amazing thing, but I'm really not. All I'm doing is supervising.
Light show teams had a virtual arsenal of tools they could incorporate, like color wheels, filters, and light sticks. All so that the youth of the 60s could revel in their own psychedelic fantasies. The 60s could be described as the nation's bipolar adolescence. We changed during those 10 tumultuous years, lost our innocence, and developed many technologies for the decades to come.